Hey guys, this is going to be a lengthy, in-depth process, but I got a really cool project to finish off this foot peg install. Made some shift linkage here as promised, using a central pivot and then a transfer basically going from forward back to up down leverage, and it works really well. So all handmade, just using steel I had here. Of course Tig welded, and there's some advanced techniques, I guess you could say. Little ingenuity, but we got it done. So in this video you're gonna see exactly how I made those, and maybe you'll get some ideas for putting some rear sets on whatever your project is, but more specifically your CX or GL series bike. So enjoy. Okay, so we're working on the shift linkage on the left side here. The challenge with the CX is the way the shift orientation is coming out of the engine. You need to move from essentially a forward back motion to an up down. So to do that, we're gonna use the Purpose Built Moto kind of way of doing it, where you basically bring a pivot out here, and it's based off of the measurement of the center point here to the length of your shift arm down here. You translate that dimension multiple times in a different plane through a bearing and a bushing and whatnot to translate the energy into the actual shift lever. So what we're going to do, I've rated all of the kind of like bushings and whatnot I have, trying to come up with something that's kind of like a machine fit. And I have a piece, I don't have it in front of me, but the problem is that it's hardened steel, so I can weld it, but I can't like tap it or anything like that, which is what I need to do. So right now what we're gonna work on is taking a piece of essentially just 1/2 inch round bar or round stock and turning it down to my drill press, since I don't have a lathe. So that's what we're gonna work on, and then I'll explain as I go how it's all gonna work, because I'm figuring it out too. So anyway, let's get to work. Alright, so I've rated all of my shock bushings here, and I have come up with, I've just been grouping things into diameters, and what I have, I started with is some, I think Yamaha XS650 starter goodies. Anyway, this is a nice machine surface, and I can use that as a bushing. Some of the shock bushings here, they're made of a thicker steel on this one. Same ID, fits nice and fits real nice on there. So I'd like to utilize this part along with this shaft. Problem with this shaft is that it's hardened steel, and I've already flattened my punch trying to get into this because I wanted to be able to tap one side of it. So to accommodate for that, I'm going to try to make this bushing out of just some 1/2 inch steel, and I've got to turn it down a few thousandths here. So I'm going to try to just chop a piece off, chuck it in my drill press, and then we'll just spend the next probably 14 or so days and whittle it down to the correct diameter, and hopefully we'll have it so we can have a nice machine tolerance type clearance there, and that'll be our pivot for the shift linkage that you'll see. I'll take it. Alright, so I got that thing turned down. Looks pretty good. I've actually never done that before. I don't know why, but that made life quite easy. So I'm going to, as you see, utilize some of these parts here. So this is one of the original bushings I was using. I'm going to use that as like my stopper. And then this will be the pivot. So I'm going to weld some bars onto this, and that's going to hold the actual shift linkage, transfer the energy from front to back to up to down. And I'm going to want that brought right out to the edge, and then I'll weld this bushing to allow a little play here. And then what I'll do is I'm going to drill and tap the end, and then I'll do a larger washer on here that's going to keep it all contained and make the whole assembly removable. And then basically this shaft and then this bushing here, once I trim it down and get it all welded up and stuff, it's going to be welded to the bike permanently, to the frame, and that will be that. So we'll get this drilled and tapped, make sure we can kind of dial in the tension, because we don't want a lot of lateral motion there, but we want it to be able to rotate freely. So we can always, that'll be like kind of like a file fit again, and then we'll go from there. The whole reason we had to do this is because the original bushing, or the original shaft here, it's hardened steel. I mean, I can't work with it, so I just had to regrind the tip on my punch here. Boop. Much better. And then we can drill and tap that. Yeah, we're pretty good. I think that's deep enough on the pilot hole.
Hey, it's Ben. Force anyone to just blindly join us. That'd be crazy. But if you like stories about doomsday cults who do exactly that and more, please join us on Spotify. Tap the banner to start listening now. Keep the back fresh for whoever's got next. Come on. Hey, hey. Got the breeze, hey, I'm just pushing you, you can't come on. Hey, hey. Pushing through you just break my breeze. Yeah. After every flush, you just break my breeze. Yeah. After every flush, break my breeze. Yeah. And breathe happy for breeze.
You better believe I'm going to keep that moment. Okay, I'm getting ready to start dragging out the welder, and what I've done is I've put my bushings on, and this is going to be welded to here. Now I've gone ahead and I put a bolt with a washer on to keep it from moving past this side, and I just went ahead and I pushed it in here, and I pushed my tap off. I pushed it in here to make this, it's kind of tight, but just to keep this from moving or rocking at all. So I'm going to go ahead and tack it from this side, and then even if this is tight, I can go ahead and I can just barely take it to the belt sander on the side of this bushing, and then we'll get the fit dialed. So that'll work good. I'm going to go ahead, like I said, get the welder out, tack it there, flip it over, tack it, and then lay a bead on it, chop this thing off, and start working on getting this actually welded onto the bike. Alright, let's see if we can talk our way through this in a way that makes sense. So we have our bushing, okay, That fits on there clean. I can tighten the bolt and washer on here and it fits perfectly. I've trimmed it back just a little bit on this side, and I'll probably end up trimming it back flush with this. But anyway, the idea behind this is that you need to translate or transfer front rear motion into up down. So what we're going to do, we're going to translate or transfer this dimension, which is just call it 50 mil. That's the dimension we're going to use. 50 millimeters from the center pivot here to the center of the hole. Now we're going to have a pull bar. When this is down here like that, we're going to have a pull bar going into a placement right here, and this is where this pivot comes in. So I'm going to have another 50 millimeter gap coming, or arm coming down from this pivot, coming straight down. That's going to tie in to the foot peg itself. Okay, and then from there it's going to basically be an L shape, and it's going to be 50 mil to the center and then 50 mil out. So I have to determine location here for that, and it's going to be 50 mil from this, obviously. So it's going to be floating in space about right here. Now that 50 mil, that's going to be up down here, and then 50 mil from that. It's also going to be 50 mil vertically from the shifter. Now I'm going to use the factory shift arm here. I'm going to go ahead and put it upside down for a kind of a downward bend to it. Just gently set it on here. I'll end up cutting it so it's 50 mil, and then I'll tap it just like I did the center of this piece, and then we're gonna have a couple tie rods or a couple rod ends just welded together at 50 mil. I'm gonna keep repeating that, so you're gonna get tired of it, but that's gonna sit 50 mil high, and that's gonna translate into the arm. Okay, so everything's gonna operate. It's gonna be kind of complicated, more complicated to explain, but once you see it kind of come together, then you'll be like, oh, well, I get it. Anyway, we're gonna keep working. Okay, we're making a little headway here. So the shift arm I've cut down, and this piece right here, since I'm going to be using that 50 millimeter measurement so many times, I cut just a piece of round stock down to 50, and I use this as just to compare, to make sure I'm at 50 instead of continuously adjusting my calipers here. So the idea that I'm going for right now, off the shift arm, you have your rod end, going to want the center of the rod end at 50. So that's going to get me super close. Now I went ahead and I trimmed down, I just cut off the head of a bolt, and I'm going to weld that to the stud, or to the shifter arm here. And then once this is on, and that's assembled like that, once that's welded, that's right at 50 mil. Okay, so that's the first piece of the puzzle. I'm going to go ahead and get this welded, then I'll trim this back as needed, and then this should allow a nice range of motion once on there, which is what we want. Alright, it's a good looking little piece there. Next step is we need to make the rod ends 50 mil. So I went ahead and put a piece of all thread in this as like a sacrificial piece so I can put it in the bandsaw, because I need to trim just past here. And this, like, I can't even clamp it in the vise in a good way, so we're just going to do some sacrificial all thread, chop it off a little bit before there, same spot on the other one, and then we'll weld them together and it should be right at 50. That's about to be expected there. That was a little funky, but that's what I figured what would happen. Okay, first component off of the shift lever. So I went ahead and I've cut these down as you saw, and then I went ahead and cut a piece of all thread, and this is just to add a level of safety to this piece, just so it doesn't break. Or let's say the weld fails, then this piece inside the sleeve will strengthen it further and keep it from having any kind of catastrophic failure. So here's my 50 mil, center to center. Looks good. So I'm going to probably bevel this a little bit and then just lay some weld in there, and then this piece will be done. And then we'll move on to the next project. Alright, we're back on the CX. It's a new day, and we're going to finish this shift linkage today. So as of now, I have the first of the tie bars made. And now I need to get my pivot point made to make all of this magic happen. So remember my 50 mil. So that is 50 mil from there to there. I have the same height. So I'm gonna go ahead and cut this out of probably some 3/16 steel, because I do not want this to deflect in any way. I need it to be very rigid. So we're gonna get this this little template made here. I tried to shape it in a way that was like kind of follow the lines of the frame. Again, kind of just not wanting to draw attention to that area, but I think with all of the linkage being like polished and stuff like that, you won't notice that little bracket. But I'm gonna go ahead and get that made, and then we'll cut a hole for this bushing to fit within, and then this is the section that's gonna be welded. So we're gonna rely on that to not have any kind of twist in it. And then from there we can build off of the sleeve, which will allow us to tie in this link bar along with this. So remember, it's going to be like an L shape. We're going to make it happen. Alright, so I've got my piece, my template transferred onto some 3/16 steel. And to cut the radius out of here, instead of trying to do it the hard way with a die grinder and flap disc and stuff, I'm just going to start with a hole saw, and then I'll just open it up from there. It's a lot less work. And then I've got my center mark for the front pivot, so I'll leave that for now, and then we'll just go ahead and get this cut, because that's going to be the hard part. If you cut this piece out and then try to do that, it's just jump around the vise and stuff. And anyway, do that first. Save us some headache. Alright, so here's our bracket with the original pin that we made, or the pivot. The mechanism's going to ride on the pivot. I'm going to weld this to the plate on both sides. And then this fits up on the back side, approximately like that. We're going to do our best. There we go. Make that balance. And then we've got our 50 mil. Okay. And then there's going to be, from the same thing, there's going to be an L. Like I mentioned, we're going to have a little tie bar, but 50 mil down. And then that's going to connect to this linkage right here. Time to weld. Alright, we got our pivot welded on, just tacked in place in a couple spots to keep it square. And then I've got a piece made here to weld to. So now I'm going to go ahead and measure the gap here, because you know it's not quite 50, taking up the thickness of that. Anyway, we're going to have like a little inward bend on this one, and then probably like a little outward bend to meet with the foot peg. But I'm going to go ahead and get a little piece cut here. That should take just a few moments, and then get that tacked in place, and then from there it should start really taking shape.
It's like, don't even waste my time.
Someone must
It was
have.
just funny the way he said, because he really is that guy. He's like the I'll save lives, like he's a doctor, he cares.
Right.
But on this one, he's like, man, you better just don't even waste my time.
When you heard about that, you had to think this has got to be like a fucking movie. This is almost like a movie.
It's if it wasn't real, it would be hilarious, you know.
Right.
And then the other thing is that the fact that like Lysol had to put out a thing like not for internal use, like the idea that they know there are people so dumb that they're like, we better tell them not to do this.
There's got to
right?
be a few that thought about it. There has to be a few that thought about it. There was a thing that I tweeted.
Alright, so we got the top link bar made. Put a nice little curve in it, and then dressed up this piece right here. Gave a radius on the end, just going that extra mile on this thing. So we're gonna do almost the exact same part. We're gonna bring it down low, and then that's gonna hook up to the lower peg. So, and then we will be in the home stretch. We're gonna make a little link bar from here. That radius is down as well, just for more strength. Alright, we're getting ready to make the final link bar for this. Now, this needs to remain adjustable, obviously to adjust the peg for rider comfort. So I'm going to probably chop out most of this bar here. There's going to be about 1.5 inches of just non-threaded area. And this has left and right hand threads on it, so then we can just twist this and then that will adjust this as needed. So once we have that welded together, then I'll have this kind of in place. It'll be looking good. And we'll make a link bar here. Probably do another double curve because I think that's looking pretty awesome. And then once we finish weld it, this thing will be shifting. Looks good though. I like where it's going so far. Alright, so after way too much work, way too much grinding, welding, bending, fitting, just, it's a lot of work. It's done. So check it out. Got our pivot right here. Our transfer of motion from forward back to up down. Pretty slick. So I'm going to weld this a little bit further. I still have to weld that, and then I'm probably going to add a gusset. I'll see how it does just by welding this all the way down. But if it does flex, I'll just add a gusset right here, and then that'll control everything. It'll just be rigid, but kind of doubting I'll have to. But yeah, pretty long process, but I think it's worth it. It just looks super clean. So anyway, hope you guys maybe picked up some ideas. But I'll try to link below, just some of the components I've used. I'll link the foot pegs again, but you can use kind of whatever you want on these. As long as they're indexable, or if you're duplicating this, and you're going to get close enough by having one that's just 90 degrees down. So yeah. I can't show it with one hand right now, but I do spin the output shaft of the engine, and it does go through the gears. So it clicks in nice. Feels nice on the bike. Yeah. I'm pretty happy with it.